Good morning to everybody and welcome to this mixed session. Part of the audience is in Trieste and part is following from home. Like me, I'm in Milano and our speaker is in Bergamo. First of all, I would like to thank you all for joining us physically and virtually for this keynote presentation, the Darwinian lesson of COVID-19. My name is Gianmattia Bazzoli. I'm Deputy Editor of Focus, the leading magazine of popular science in Italy, and I'm very pleased and really honored and proud to introduce our speaker, Professor Telmo Pievani. He's a full professor at the Department of Biology at the University of Padua, where he covers the first Italian chair of philosophy of biological sciences. He also teaches bioethics and science communication. Since 2017, he is president of the Italian Society of Evolutionary Biology, and he's a fellow of several academic institutions and scientific societies, including MUSE, the Science Museum of Trento, where he's a fellow of the scientific board. But I would like not to focus only on his academic curriculum, that is huge and very impressive, but also consider that Professor Pievani is one of the most important, recognized and influential Italian science communicator. He's author of 242 publications, including several books, I counted 20. He's director of Picaia, the Italian website dedicated to evolution. He writes books for children and scientific shows for theater. He's a columnist for Il Corriere della Sera, the leading Italian newspaper, and for magazines such as Le Scienze, that is the Italian edition of Scientific American. It was in 2003, so a long time ago, when he started to cooperate as a fellow of the scientific board with the first science festival in Italy, in Genoa. At the time, the science festivals were not so common, so he contributed to develop the culture and the influence of science festival, not only in Genoa, but also in Bergamo, with Bergamo Scienza, where he's a fellow of the scientific board. And ultimately, he contributed to build a better scientific knowledge here in Italy. At the end of the day, Professor Pievani has a multi-faced experience in science communication. If we combine this background with this deep knowledge of evolution and biology, we have the perfect speaker for this lecture. A talk that will focus our attention to the Darwinian lesson of COVID-19, an important lesson, I think, not only for scientists, but also for media, journalists, politicians, of course, and all the public opinion. Before starting, I'd like to remind you that at the end of the talk of Telmo Pievani, there will be a short session of Q&A, 20 minutes, more or less. So feel free to send your question. In the meantime, we are very, very happy to listen to what Professor Pievani can tell us about COVID-19. So, Professor Pievani, thank you very much for joining us, and the virtual floor is yours.
Thank you. Thank you so much, Gianmattia, and hello to everybody. Good morning. And thank you, Gianmattia, for your kind and very kind presentation. And to all the organizers of As of 2020 for inviting me for this session. The title of my talk could seem quite provocative and is the Darwinian lesson of COVID-19. Why? For a very simple reason, because so far we have interpreted COVID-19 pandemic from, of course, multiple angles. The epidemiological one, of course, the clinical, the healthcare side, social, even political, and so on. But all these perspectives are based on the present. What is missing for me is a vision based on what we call in evolution a deep time. So my proposal is that we should look at COVID-19 through evolutionary lenses. And this has also implications for science communication, as we will see maybe at the end of my presentation. I don't have slides because I'd like to share with you and with the audience just an argument, a very brief argument. So let's start my argument with a very simple fact. About 20% of human DNA comes from viruses. Quite amazing. This means that our genome is not pure. Nothing is pure in biology, in evolutionary biology, fortunately. It means that not all DNA is made up of protein coding genes, but we understand that there's much more in our DNA than genes. But mostly, it means that our ancestors, since we were born in Africa around 200 millennia ago, have survived many pandemics. So then what we understand here is that COVID-19 is a very old story, and such viruses come from a very long way off. In evolutionary biology, the relationships between pathogens and their hosts are explained through a very interesting metaphor, the Lewis Carroll metaphor of the Red Queen. That means that we have to run faster and faster to appear firm and stable compared to an ever-changing environment. So we have to run faster and faster in order to seem stable. So the evolution in the Red Queen mode is a continuous game of moves and counter moves, challenges, reactions, new challenges, and so on. So adaptations and co-adaptations. And this is exactly what happens with the relationships between hosts and pathogens. And the risk in these arms races, the so-called arms races, is that the host, like us, could be always a bit late, a bit behind the pathogens, which change, we know, faster and diversify better than we do. So, therefore, we must be very careful with viruses in an evolutionary perspective, viruses such as COVID, for at least, for some reasons, for at least four main, schematically speaking, four evolutionary reasons. The first one is that RNA viruses are much older than us. They have been running around the planet for at least 3 billion years, 3 billion years, while we are a very young African species. So for billions of years, viruses have evolved strategies to infect bacteria first, and then multicellular plants and animals. The second reason is that viruses respect and obey, we could say, a very simple logic. That is, to make copies of themselves, using the cells of others as vehicles of diffusion. So they are quite perfect replicators, as Richard Dawkins said in the book. So they are quite perfect replicators with a very simple structure. In the case of COVID, an RNA strand surrounded by a protein capsule and nothing else. A very simple structure that minimizes the resources and costs needed to obtain the maximum benefit from a Darwinian point of view, that is reproduction. The third reason is that viruses, especially RNA viruses, mutate and change much faster than we do. Because RNA is a more unstable molecule, is a more unstable nucleic acid. However, I have to say, this COVID-19 surprisingly changes and mutate little, probably because it has good and efficient mechanisms of correction of the mutations. But in any case, this virus, as many others, it was born from a genetic recombination between a bat virus, likely, and another virus coming maybe from an intermediate host, animal host, maybe pangolins, we don't know exactly. Anyway, viruses are faster than we are. This is another reason of great difference between us as hosts and viruses. And finally, the fourth reason that's very important, Homo sapiens is a great host for viruses, being a social and mobile mammal, exactly like bats, mobile and social. So thanks to our individual genetic diversity, that is our best evolutionary defense against viruses, COVID-19, we know, now we understood, unfortunately, affects some of us very lightly, with few or no symptoms at all, while affects others more heavily, and still others severely and even lethally. Nevertheless, even this is a good evolutionary strategy for a virus, because the host with light symptoms infect many other people longer and more easily, rather than patients quickly isolated in intensive care. So this is another evolutionary strategy for the viruses, to mix together lethality and to be contagious, to be more or less contagious. So after all these reasons, we should be very worried, and we should be even more concerned about viruses, because there is an additional fifth reason that is more recent in evolutionary terms. When the Spanish flu struck humanity a century ago, we were around 2 billion human beings on Earth. Now we are almost 4 times as much. We are quite 8 billion. So in addition, compared to the time of the Spanish flu, today we travel crowded on trains, ships, and airplanes. So now, and not previously, the viruses can take the airplanes with us. This is an additional reason that has been underlined by many scientists like Jared Diamond and many anthropologists. So finally, and that I think the most critical point, the Homo so-called sapiens has been implementing for decades some behaviors that unfortunately promote and favor the likelihood that viruses can spill over, so can pass from animals to humans, so doing the so-called zoonosis. And these additional behaviors are, for example, the growing deforestation and the devastation and reduction of the natural habitats of animals that are reservoirs of viruses able to pass to humans. And that, unfortunately, is happening throughout all the equatorial and tropical belt today. Then we have poaching and the illegal trade in exotic animals, which is, we have to remind, the illegal trade in exotic animals is the fourth illegal trafficking in the world, according to the Interpol police, international police, after the fourth after drugs, weapons, and human beings. So it's a great business around the world. And then we have the transportation and the bulking of these animals in the wet markets that we know very well. We have seen some of them in China, but we can find them in all Asia, in Central America, in Africa, and so on, without any minimal hygienic conditions and so on. So all this propelled by the demand of these animals as food, or for the alleged superstitious traditional medicines without any scientific basis. So we have a good problem because we are very good hosts for viruses, but additionally, we have behaviors that promote viruses. So therefore, we became a perfect host for viruses, and in addition, we do our best to promote them. I'm quite provocative, I know, but evolutionists have this non-anthropocentric view of nature that I think could be useful in some occasions. So we became good allies for viruses. And this is completely illogical, not only for human and sanitarian reason, but from every point of view, including the economic one, because the costs of a pandemic such COVID-19 are much higher and higher than the illegal and legal gains that we could have from the exploitation of ecosystems and animals, much higher. So even in a rough economic point of view, it's not convenient. So the missing side of the COVID-19 discussion is exactly this for me: the deep ecological nexus of pandemics. The evidence that pandemics are, for me, a chapter within the more general book of the environmental crisis and its cost. In evolutionary biology, we have a name for such a process. That is a process that I study in my technical papers. And the name of this process is niche construction. And it's very simple to explain. We know, in fact, that some organisms in nature, not only humans, many different organisms, have what we can call an active strategy of adaptation. They don't limit themselves to respond to environmental challenges, but modify the environment actively to make it more suitable for their survival and reproduction. For example, soil worms activities, already studied by Charles Darwin and published in his wonderful last book, written the year before he died, about the activity of soil worms, or beavers' dams, and so are very famous examples of this process. So by modifying and building their ecological niches, these species pass on their offspring not only genes, but also innovations through cultural evolution, and mostly the ecological changes they have introduced at a generation. So what does niche construction have to do with COVID-19 and with the environmental crisis? The point is that we, Homo sapiens, are the largest and most successful builders of niches, of ecological niches. For millennia, we have been changing the world to make it more suitable for us, or at least less hostile. So our descendants inherit from us genes, ideas, but also ecological changes. For example, climate change is a classical, great experiment in niche construction. We now have to adapt to an environment that our predecessors and we have intentionally changed and disrupted. So niche construction is a recursive process. Okay, we change the world, and then the world changes us through the adaptation that we have to to use it, to invent in order to be adapted to a new environment. So you know that adaptation has indeed become one of the keywords in the international documents on climate change. And adaptation is an evolutionary word. So another way to see the importance of the deep time in order to understand what is happening today. So, in other words, the exploitation of the environment is a process of niche construction, and for a long time, it's given us great demographic success, economic, social growth, and so on. However, and that's the point, niche construction can be an ambivalent or even a very dangerous game, evolutionary game, because it can lead us into something like an evolutionary trap, in the sense that the changes introduced by one generation can be unexpectedly expensive and costly for the next generation in evolution. So the faster we change the environment and the harder we adapt ourselves and the next generation to the changes we caused. So the environmental crisis is presenting us with exactly this environmental cost, in many ways, from the most violent and frequent atmospheric events and phenomena to pandemics. It's all connected, and we are paying the price for our changes, successful changes as niche constructors. So in short, coming back to the Red Queen, we could say that we are a Red Queen who has to run faster and faster because the Red Queen herself is changing the environment more and more dramatically. So it's a quite strange and new situation. So niche construction gives us some lessons, and I'm going to conclude. The first lesson is that when a pandemic strikes us, we must act and we must think about both its proximate causes in the present, so therefore healthcare, vaccines, and other scientific research gifts, we could say, but also on the remote causes of the phenomenon, on the remote causes of the process. That means we have to remove the deep ecological factors in order to avoid or make the next one less likely to happen. The second lesson is that by understanding the evolutionary logic of this crisis, we can put ourselves in the shoes of our enemy and identify his weaknesses. And we know that viruses have at least four main enemies. One is the hygiene, we know, and social behaviors. Another one is social justice and universal access to health, because pandemics are also a great topic in social justice and inequalities in the distribution of the access to health, as the journal Lancet has underlined many times in these months. Then we have the urgent defense of the environment and species conservation. I know that it's quite counterintuitive, but it's absolutely fundamental in order to prevent next new pandemics. And finally, another enemy of viruses is, of course, scientific research, and let's say the importance of which we should realize not only when we need it, but always. And that's the point. So it's clear that this pandemic has been also, and just a couple of concluding remarks about science and science communication. I know that this pandemic has been a shock, a real shock for science communication in Italy as well, but in Italy at least, but I think in UK, for example, in other countries. For many reasons, we have seen in these weeks the early uncertainties about the virus, the contradictory messages, even the quarrels and the squabbles and the fights between scientists live on TV or on social networks, very bad, the narcissisms, the unreasonable request to science to provide certainties that science cannot provide by its methodology. So I think, so a lot of problems we have seen. So I think that it's time for all scientists who have underestimated the importance of science or communication so far to be self-critical now. And for example, at a university, we are discussing a lot about that. The problem is not only the poor scientific literacy of citizens, as we always say in Italy, but also the fact that science must update the languages and the ways in which it transparently shares its methods and results. So, for example, in science communication, for me, we should admit much more our ignorance. That is not a bad word. And say, okay, we don't know yet, and we are investigating. For example, we don't know enough about viruses biodiversity. We are investigating. We need a global virome, for example, a genetic library of all known viruses, or so new proposals, new idea, new founds, and so on. That's the right way to present and discuss scientific methodology, even with the general public, the general audience. So, summing up, my idea is that science communication in a global crisis, in a global case like this, should emphasize more the ecological connections of the phenomena, on this phenomenon in the case, highlight the role of prevention in order to avoid the next pandemic. So we must cultivate foresight to see in the future. I know that it's not easy for our mind because we don't have a mind evolved for being perhaps foresight. But anyway, we exactly for this reason we have to work a lot on this. Science communication should remind everyone that science can be slow. Of course, we regret this, but it's necessary to have guarantees on the results of science. And despite even any geopolitical and nationalistic interests, like in the case of vaccines and so on. And mostly, for me, science communications should value more the fact that science has to do with uncertainty and ignorance. And ignorance that paradoxically is generative of ever new and new knowledge. In so doing, with good science communication, we could share with the general audience not only science as a product, but that is much more important, science as a process, as a genetic process, as a fallible, imperfect, but wonderful human enterprise. So this human enterprise in my field has found that viruses are more effective than we are in the Darwinian game, that we are vulnerable, that we are connected to the rest of the biosphere, and for me, mostly that we are not indispensable for the biosphere. And I think at the end that this is the most important lessons that we can learn from evolution, that I would call the evolutionary humility. So a different point of view, even with respect to viruses and their hosts, like mammals like us. So thank you, Gianmattia, thank you all, and I'm open and welcome, and any question is welcome for me now. Thank you.
Thank you, Professor Pievani, for this beautiful presentation. You gave us some very interesting hints, and there are so many things that I could say from your presentation. Just choose some important points that make me think very much like the thing that we survived a lot of pandemic in our very short history compared to the viruses, but also the self-criticism that you said about the scientific community. This is an interesting thing also, and the part about the science communication. I have some questions that came in mind after listening to your presentation, but first I would like to give an answer, that you give an answer to some questions that are coming from the audience. Does the Red Queen picture applies to us? And there are evidences that Homo sapiens is in a post-evolutionary phase. We live much longer than our reproductive age and reproduce much less. Does the Darwinian picture applies to a species that has saturated its environment's resources?
Oh, very good question. Very interesting and very hard to answer, because the answer, I think, in this case is yes and no. Yes, due to the fact that, sure, our friend is right in saying that Homo sapiens is a very new and strange species. We cannot apply to Homo sapiens a lot of classical evolutionary factors. For example, speciation. Speciation, the birth of new species are due in evolution due to the fact that you have a small population that at some point in evolution became separated, isolated from the mother species in a new environment with genetic drift and other evolutionary factors. And so you have, at the end, after many thousand generations, you have a new species. This is not possible, no longer possible for us, because exactly as in the question, we have saturated any possible environment on Earth. So this is an example of the fact that yes, the answer is yes. But the answer is also no, because it's not true that we are now completely emancipated with respect to nature, biosphere, selective pressures. Evolution is a very slow process, but we can see it ongoing even in Homo sapiens. And this is mainly due to the fact that now we are the builder of the ecological niches. So we have to expect, and we are seeing right now, that new mutations, new changes will appear and will emerge in Homo sapiens due to the fact that the environment is changing, as always in the Darwinian evolution. But in this case, what is new is the fact that more and more the future evolution of Homo sapiens will be due to our technological changes, cultural changes, and environmental changes, like climate change and so on. For example, gene editing applied to human embryos will be a new factor of evolution, because for the first time in our history, we will be able, and we are going to be able, in a fast way, to change the germinal line of our evolution. So to change the inheritance of genes in our evolution. So this is another example of a technologically mediated evolution that we have to expect for our evolution in the future.
Another question is about the enemies of viruses. You said that we have scientific research, hygiene, social progress, and defending the environment. Which is the most important from your point of view? Probably you just answered to this question according to the time you spent about the environmental crisis we are facing. But I would like you to focus more about these enemies.
Yeah, I think that exactly like in the case of climate change, we have many possible actions to implement and to do. And what is important to outline is that we have to do all these actions together now. So we have to apply something like a systemic approach to the actions we need. So even in the case of viruses, we have to apply all these actions and work on social behaviors, environment, scientific research, and so on. But from my point of view, the priority should be given to the ecological intervention, to the environmental intervention, because they are the real remote causes of such pandemics. So we have to remove the deep radical causes of these pandemics. Pandemics are unpredictable. it's a long story. They are a long story, as I said. So we have to expect other pandemics because they are part of our evolutionary story, as we see in our DNA. But we are a prescient and an imaginative species. So we have the duty to reduce the likelihood of these pandemics due to the cost that they have, due to the price that we have to pay for this pandemic and for possibly future pandemics. So coming back to the previous answer, we can change our actions in order to intentionally direct in a better way our future evolution in order to reduce the probability of future pandemics. We have the tools, we have the power to do it. We have to direct this power in this way. And I have to say, unfortunately, that so far we are not doing that. For example, in China now we have some new regulation that reduce the traffic of animals for food, for example, but less reduction for animal exchanges for traditional medicine. So it's not enough. We have to do much more in order to prevent such behaviors, like in the case of the illegal trade of animals that are reservoirs of very dangerous viruses like COVID-19.
A question about science communication. You point out that this pandemic came in a situation like a perfect storm. Homo sapiens, the host, travels very fast and everywhere, and also information travel everywhere, even faster with the internet and social media. And we saw some misinformation, inaccurate information, of course, and I think that media, I'm a representative of media.
You are responsible.
Exactly. We are responsible, we are inaccurate, we have been inaccurate in some cases. We have the problem that we have to communicate to an audience that is anxious to have a certain, clear, and immediate answer, and science cannot give this kind of answer. But we saw also in this crisis another virus, the virus of fake news. What's your opinion, and what's the difference between the SARS-CoV-2 virus and the fake news virus?
And that's a good point, a very good analogy for me, and for many reasons, because exactly like in the case of COVID-19, so a biological virus, also cultural digital viruses like fake news have different reasons for their success. And I think that we have to understand exactly, analytically, all these reasons. We know that fake news are very successful in the niche, because also even the web is a cultural niche for our mind, because our mind are immersed in a new environment, included our technological inventions, our new infosphere, like Florida said. So we are immersed in a new environment. And our mind have to adapt to a new environment. And the web is an environment where it's very easy to find very consolatory thoughts and consolatory stories. And fake news are very consolatory. They are narratives very effective for our minds, because we know that we have teleological minds. So we love so much narrative with a purpose, with hidden agents. So we love these plots, these mysterious plots. They are very successful for our minds. So what I'm saying is that the success of fake news is due to, we know, economical reasons, the fact that they are successful, and then you have advertising, you have a lot of likes, so you have the processes of self-improvement of the success of fake news. According to a very good survey concluded during the lockdown in Italy, a society for the observation of the public perception of science in Italy quantified that more than 22% of Italian citizens follow news about pandemics, about lockdown, only in informal sources. That means social network. And they were exposed only to not checked, not controlled information. So not like in your case, you have a board, you have a process, and we can check the information coming from your board. This is not the case of the completely anarchic and informal information on the web. And more than 22% of Italians were just focused on this kind of information. So this is a part of the problem. But for me, we have to consider also another part. So the fact that fake news are very successful for our mind. They are very intuitive. And on the opposite side, science is counterintuitive. Science is hard. From the scientific side, mostly we have to share bad news. For example, the fact that the process of vaccine will be slow is a bad news for many persons, for many people. It's a bad news, and we have to share, and we have to learn to communicate bad, uncomfortable news. That's the point. And on the other side, fake news are very, very comfortable. This is something very similar to the debate between evolutionists and creationists in the USA. I participated to many of such debates. On one side, you have the scientists that have to explain a reasoning, an argument with a logic, with a date, with the data. So he needs time. He needs to share in a correct way a content. On the other side, you have the slogans, you have fake news, you have false messages that are false, but they are very easy to understand, and they are very easy to be efficient in our mind. So it's an unfair debate between science and fake news, and we have to take into consideration this unfair debate. For example, not accepting direct debate between diffusers of fake news and scientists is I think is not a good idea. Scientists have to communicate in an indirect way against fake news, and the best way, according to many papers, recent papers, the best way to react to fake news is not just to rebut one by one the fake news, but to share with the people the tricks of the fake news. So to diffuse something like an antidote against a vaccine against this virus. And the vaccine has a critical interpretation, critical thinking, and the freedom of thinking for me.
Thank you. But when you last compared the debate between fake news and science, you mentioned the debate between scientists and evolutionists and creationists. This seems to me a little bit pessimistic, because I don't see any chance of resolve this debate that is going on since Darwin. Let's see. But are you optimist in this case? So can we find? Can we use a vaccine to fake news, or there will be always fake news and people that believe to fake news?
Okay, if the question is related to can we be able to convince creationists or diffusers of false messages, anti-scientific, pseudo-scientific messages, I'm quite pessimistic. I'm quite pessimistic because even and mostly in the more recent situation in the web, you know that in the web we have echo chambers. So we have a situation where people are close in communities where all think in the same way, and the heterodox thinkers are seen as something completely unacceptable. So we are inside a dynamic of self conviction that is very, very hard to defeat. So I think that it's better to use, even in this case, a differential strategy. So rebuttal. So the fact that people can find on the web and in different places all the information in order to rebut the fake news, okay, case by case. But also we need another part of the story, of the action. We need to diffuse the vaccine, so the methodological vaccine against fake news. For example, explaining to people the tricks of the fake news, the ways through which they are able to diffuse false messages. And at the end, science has to be very honest and transparent, for example, in order to share any debate inside science. Just an example, fake news is related to the fact that maybe COVID-19 has been made in a lab. So it's a product of biotechnology. We know that it's not true, but it's not enough to say, no, it's true, that's a false, that's a fake news. You are completely ignorant and you are giving bad news into debate. You have also to explain that we use viruses in the lab. We use biotechnologies applying to the virus in many different labs in the world. You have to explain why we improve, for example, we have the gain of function biotechnology for the viruses, because the purpose is to try to prevent and to understand better the strategies of a virus, for example, the aviarian viruses and so on, in order to be faster if in the eventuality that virus can able to have the zoonosis and come and arrive and pass to humans. So we have to explain the fact that we use viruses in the lab, why, for which purpose. You have to say that in the scientific community there is a debate. Not all scientists agree with these technologies, because many scientists think that they are too dangerous. Okay, so you have to explain everything in an honest way, and then conclude that in this case, in the case of COVID-19, we don't have any evidence of the fact that COVID-19 has been made in a lab in China or elsewhere. This is a very honest, open answer to a problem that people feel very in a very diffuse way in the audience.
Thank you, Professor Pievani. Very beautiful presentation, very beautiful talk. Time is over. Thank you very much.
Thank you to you all and to Heads Off organizers.